All right, everybody, welcome back. We're going to do some more testing, hypothesis testing around means on this one. But this time, we're not going to know what the standard deviation is of the populations. We're not going to know what sigma is. So I hope you remember from confidence intervals, what we're talking about here is those student t curves. All right, and that means that it's a family of curves. Now, remember how this worked. If there were, let's talk about our assumptions. It's always good to talk about our assumptions. All right, first things first. So one, your data is randomized when it's collected. So one, simple random sample. Number two, if pop is known to be normal, n can be any size with degrees of freedom equal to n minus 1. Number three, if pop is unknown distribution, unknown distribution, then n needs to be greater than 30. Remember, that's when the central limit theorem really starts to kick in. If I don't know what the shape of the distribution is, then I have to, I've got to collect at least 30 data values. And then again, degrees of freedom equals n minus 1. All right, so let's test these two claims with the following data. Step number one, or excuse me, claim number one. The mean speed of all cars in California is greater than 65 miles an hour on, say, I-5. The mean speed. All right, so let's write up our alternative, or excuse me, our null and our alternative hypothesis. The mean speed, the average speed, is greater. In other words, everybody in California speeds on I-5. All right? The null hypothesis can be written as less than or equal to 65, or we can just, for simplicity's sake, say 65. Okay? Let's say that we gather, I don't know, let's let n equal, say, 40 pieces of data. And we end up with an average of 68.4. This, by the way, is miles per hour. And a standard deviation of the sample, remember, that's really, really important, of 5.7 miles an hour. Okay? Now, you got to start being able to visualize what the distribution is going to look like. I'm going to do this one with critical values, all right? We'll do it with p-values. I can't do it with a confidence interval. You can only do confidence intervals with the ones when it's not equal to. I hope that I've beaten that into your brain. And you don't ever have to do one of the three. You know what I mean? If this were not equal to, that doesn't mean that you have to use a confidence interval. Okay? All right, so let's draw this sucker up. We will do a confidence interval on the other one because I didn't do one with the Z one that we did before. Okay, so here we go. We got 65 here, but really we know that's going to translate into a 0. And then let's see. I don't know. Let's do alpha equals, let's stick with alpha equals 0.05. For all of these guys, I'm going to do alpha equals 0.05. Okay? Now, there's my critical value. All right, now I'm going to change my colors because I like pretty red. So this guy right here is alpha equals 0.05. Now, my test statistic is going to be t. All right, it's a studentized t because we don't know what the sample, or excuse me, what the standard deviation is. Excuse me. So t is, remember how it was, it's x bar minus mu over s over root n. However, finding this critical value is going to be a little bit more tricky. So bear with me, and I'll show you how it's done. All right, so here we go. I have a different chart. Notice that this, I think this one looks like the one that you guys have out of your text. Right here, I have this guy right here. Now look, it's kind of confusing, but we're not afraid. If I go back over here and I look, this is one tail. Remember, the inequality always points in the direction of the tail. So I got a one tail right, and I'm looking at 0.05, right? That's what alpha is. And look, 0.05, all right? So wait, let's go back here. You know what I missed? I missed something. God bless it. I need degrees of freedom, which is 39. All right, nothing too crazy. So let's go back to our formula. We're looking at 0.025. We're going to scroll down until we hit 49, right? Let's see. Oh, look at that. Your author chooses to stop at 30. At 30, if you look at it, because it appears to be such a magical number, they're going to call it at 1.645 in the one tail. Now, we've seen that before. But see, they're claiming that because n is so big that we can just go, well, screw it. It behaves very much like the z term, which that's great. Remember, the central limit theorem kicks in when n is at 30. Now, you may not always see that. Sometimes you'll see it where this number will be just a little it's a little bit different, and we'll play with all kinds. Okay, so let's make sure we got one tail, 0.05. I stumble all the way down and past 29, I get 1.645. Well, that's cool. That one works very much like our z. So this critical value is 1.645. All right, this is defined as our critical region. And then up here, I'm just going to plug and chug. Let's see, t equals 68.4 minus 65. That's not a 0.65, that's just a residual. 5.7 divided by the square root of 40. All right, and I let my calculator do the hard work for me. So let's see, what is that? 3.4 divided by parenthesis 5.7 divided by the square root of 40 and paren, and I end up with 3.77. Hey, wait a sec. 3.77. If this is 1.645 and that's 3.77, now that's a big number, so we got to be careful here. Let's be real careful. That makes sense though, right? This is 3.4. I'm dividing by a number that's less than 1. Well, let's see. Yeah, look at that. So it's definitely going to be bigger than 3, so 3.77. So I'm going to be way, let's change my colors just because I like to. I'm going to be way out here. Guess what? Here we go again. Since t, now we're talking about t, got to be careful. You got to pay attention to a lot of things in this. Since t is equal to 3.77 and falls in the critical region, this implies we reject the null hypothesis. It appears there is evidence that California drivers drive faster than 65. Ta-da! Reject the null. Chaka, this one's gone, which means accept this bad boy right here, and we're set. Now, let's do a p-value one on it, okay? Now, again, using these t-charts is a little bit trickier. All right, we know one thing. So this is going to be for p-value, since t equals 3.77. Now,